Is blue light actually bad for your eyes? No. And if you think about it, it's kind of stupid. Is this blue? Is this blue? Where does blue start and end? But does it screw your sleep up? Kind of. But it's more because of your brain than your eyes, and how monitors are actually built. Every screen you look at, let's say a phone or a fancy gaming monitor, most modern displays use one of two technologies, LCD or OLED. Let's start with the most common one, LCDs. LCD stands for Liquid Crystal Display, and they're essentially elaborate sandwiches of different materials. At the back, you have a layer of LEDs that produce white light. This is called the backlight. This light passes through a polarizing filter, then through a layer of liquid crystals that can either block light or let it through, depending on the electrical current applied to them. Finally, the light goes through color filters that create the red, green, and blue subpixels you see on screen. These subpixels are arranged in different patterns depending on the display. Some use RGB stripes, others use pen tile arrangements. These arrangements affect the perceived resolution and color accuracy of the display, but they all work on the same basic principle, and it involves mixing different intensities of red, green, and blue to create the millions of colors you see on screen. Remember that backlight in LCD screens? Those white LEDs aren't actually white LEDs, they're blue LEDs with a yellow phosphor coating. Wait, what? Yep. True white LEDs are difficult and expensive to manufacture, so instead, engineers use a clever trick. They take a blue LED and coat it with a yellow phosphor material. When blue light hits this phosphor, some of it gets converted to yellow light. Blue plus yellow appears white to our eyes. So that's why a blue LED coated in phosphor makes it look white-ish, which results in a big spike in the blue region of the spectrum, which is usually around 450 to 470 nanometers. It's an optical illusion, but it works. So when we say white LEDs, it's kind of a sneaky term. What's really happening is that these LEDs are pumping out a whole lot more blue light compared to the other colors in the spectrum. It's just part of how they're made. This same technology is the backbone of the displays in your smartphone, your tablet, your shiny LED television, and even the majority of modern indoor lighting fixtures. We're basically swimming in bluish light all the time. Speaking of those devices we stare at all day, let's talk about making what's on them look amazing. So, today's video is brought to you by Mobbin, the ultimate design inspiration platform for creators like you. Imagine having access to over 500,000 real-world app screens and 80,000 user flows from 1,200 industry-leading apps all at your fingertips. That's Mobbin. And I have a 20% discount for it just for you. Forget sifting through conceptual designs or manually taking screenshots for hours. Mobbin empowers you to find highly relevant design references in seconds. Whether you're benchmarking competitors, researching UI patterns, or staying up to date with the latest trends, Mobbin has you covered. With powerful features like NLP search, visual search, and text in screenshot search, you can find exactly what you need when you need it. And with their Figma plugin, you can export screens directly into your workspace. From freelancers to enterprise teams, Mobbin offers plans to suit every need. Join over 870,000 designers worldwide who are using Mobbin to create great digital experiences faster and smarter. Check out Mobbin today and elevate your design game. Links in the description below. Now back to the video. But why blue and not green? Well, the reason behind this engineering choice boils down to efficiency. Creating white light using a blue LED with a phosphor coating is a much more energy-saving approach compared to other methods. And this isn't just true for computer monitors. This same technology is used in smartphone displays, tablet screens, LED televisions, and even most modern indoor lighting. We've surrounded ourselves with light sources that have an inherent blue bias. And this wavelength range just happens to overlap with something really important in our biology. Inside your retina are specialized photoreceptor cells, or some kind of rods, that handle low light vision, and cones that detect color. The cones come in 3 varieties sensitive to different wavelengths. L cones for long or red wavelengths, M cones for medium or green wavelengths, and S cones for short or blue wavelengths. But a third type of photoreceptor, called intrinsically photosensitive retinal ganglion cells, or IPRCGs. That's a mouthful, so let's just call them blue detectors. Unlike rods and cones that help you see, these blue detectors have a totally different job. They send signals directly to your brain's master clock, the suprachiasmatic nucleus in your hypothalamus. This tiny region of your brain, containing about 20,000 neurons, controls your circadian rhythm, or your internal 24-hour cycle that tells your body when to be awake and alert, and when to feel sleepy and rest. And guess which wavelength of light these blue detectors are most sensitive to? Light between 460 and 480 nanometers. Right in that blue range where our screens have their peak emission. This is not a coincidence. For most of human history, the only significant source of blue light was the sun. When it sets, blue light disappears from our environment, and our brains start producing melatonin, which is the hormone that helps regulate sleep. And now, we're bathing ourselves in blue-rich light well into the night. There's a study published that looked at people reading on a light-emitting device before bed, like a tablet or phone, versus reading a regular printed book. What happened was that it took people around 10 extra minutes to actually fall asleep. They also noticed that people felt less sleepy in the evening, even though it was bedtime. And here's a big one. They got about 55% less of that crucial REM sleep. Plus, the next morning, people reported feeling more groggy. On top of all that, their melatonin levels were significantly lower. But here's where people get it wrong. That doesn't mean blue light is damaging your eyes. It's not frying your retinas or anything. What it's messing with is your brain's sleep-wake cycle. Think of it like caffeine. A cup of coffee at 10 a.m.? Great. A triple shot at 10 p.m.? Terrible idea. Blue light at night is the same deal. It's not breaking your eyes, but it's just sending your brain the wrong signal at the worst possible time. Blue light is higher energy than red light because it has a shorter wavelength. In physics, the shorter the wavelength, the higher the energy. And in extreme laboratory conditions, intense blue light can cause photochemical damage to retinal cells. But, and this is a huge but, the blue light from your screens is nowhere near intense enough to cause this kind of damage. The blue light from the sun is much, much more intense, and we've evolved to handle that just fine. Let's put some numbers on this. The luminance of a typical computer screen is around 100 to 300 nits. The sun is about 1.6 billion nits. So if you're worried about blue light from your screen rather than the sun itself, you might be worrying about the wrong thing. And the eye strain many people experience from screens is more related to the fact that we blink less when staring at screens, about 1/3 as often as normal, and our muscles get tired from maintaining the same focal distance for hours on end. The good news is that technology is evolving to address these issues. OLED screens, which are becoming more common in high-end devices, can potentially emit less blue light overall since they don't use a backlight. Their individual RGB pixels can be controlled directly, allowing for more nuanced color management. So in a way, blue light isn't bad, but the way we use it kind of is. Monitors are built to be bright. Your brain is built to sleep when it's dark. That's the conflict. Your eyes will be fine either way, because we now understand that these nuances matter, and sometimes what we don't see is just as important as what we do.